For this problem, we're given the position function of a particle. It is given to be s of t is equal to t cubed minus 12t. And we have to interpret this function to determine when the particle is moving backwards and forward, has velocity 0, is speeding up, and is slowing down. For any problem like this, I recommend finding the derivatives first, and then we'll deal with the interpretation second. So there's the position. So the velocity will be the derivative of position. So that's equal to 3t squared minus 12. And then after that, the acceleration will be equal to the derivative of the velocity, which is going to be 6t. Okay, now when is the velocity equal to 0? So the velocity is going to be equal to 0. So I'll do the third part first. The velocity is equal to 0. That means that 3t squared minus 12 is 0. And so that means t squared is 4. And so t is equal to 2, or t is equal to negative 2. And so those are the two places where the velocity is 0. So t is equal to 2, and t is equal to negative 2. Now, to figure out where the particle is moving forward and moving backward, I have to figure out where the velocity is positive and where the velocity is negative. So let me draw a number line here, and I'll put those 2 points here, 2 and negative 2. And so this is going to be my velocity. All right, now I can figure out where the velocity is positive and negative. There's a couple ways of doing this. One way of doing this pretty quickly is just plugging in points. If I plug in, say, negative 3, I would get 3 times negative 3 squared minus 12, which is 27 minus 12, or 25. The number 25 is not important. What is important is that is positive. And so the velocity is going to be positive in this region where I'm just to the left of negative 2. Okay, now how about between them? So if I plug in 0, well, that's easy. So I get 3 times 0 minus 12. That's equal to negative 12, and that's negative. So in between, the velocity is negative. And if I plug in plus 3, I would once again get 3 times 3 squared minus 12. That once again is, well, not 25, it's 15. Again, the number doesn't matter. What's important is that it's positive. Okay, so it's moving forward when t is less than negative 2, and is moving forward when t is greater than 2. It is moving backwards when t is between 2 and negative 2. Okay, so that's the first few parts. To figure out where it's speeding up and slowing down, I have to work with the acceleration. Clearly, the acceleration is 0 when time is 0, and that's the only place. On this side over here, the acceleration is positive, and on this side, the acceleration is negative. If I plug in something that's bigger than 0, I get something that's positive. If I plug in something that's less than 0, I get something that's negative. So I can do that without even plugging in numbers. All right, now when is it speeding up? It is speeding up when the velocity and accelerations are either both positive or both negative. Okay, so in this region out here, so let me just kind of mark these with green lines. In the region to the right of 2, the velocity and the acceleration are both positive. So it is speeding up when t is greater than 2. Furthermore, if I look at this region here between negative 2 and 0, the velocity is negative and also the acceleration is negative. And so between negative 2 and 0, it is speeding up. It is slowing down when the velocity and accelerations have opposite signs. So here, the velocity to the left of negative 2, the velocity is positive, but the acceleration is negative. So to the left of negative 2, the velocity and acceleration have different signs. Likewise, between 0 and 2, here the velocity is negative, here the acceleration is positive, and so between 0 and 2, the particle is slowing down because the velocity and acceleration have different signs. And so that is the sign analysis that would do in order to determine whether or not the particle is moving forward, backward, is temporarily stationary, or slowing up, or speeding up, or slowing down.